Okay, for 86, again, I'm going to discuss the region. And the region, looking at the y first. Let's take a look at this. So I'm looking at the y first, and I'm going to say 0 to x squared. Let's write this over here. So y equals 0, lower. Y equals x squared, upper. What does that look like? Well, y equals 0 is just the x-axis, and then you got a parabola that looks like this over here. All right, now let's look at the x's, and the x lower is 0, and the x upper is going to be root pi over 2. So I'm seeing a region over here somewhere, so this thing right over here. Now, granted, I'm looking at this thing, I'm wondering, can I integrate it as it stands? And I think I can. And let me go through that. By the way, I want to look at the picture for 86, though, and see if they provided one. It's figure 25 on page 79. It's, again, that's the picture, all right? Certainly the picture on the computer is much better than the picture I did over here, though. I hope you can agree with that. So what I'm going to do over here is just make an attempt to integrate without changing anything. And it looks like it's doable. For example, I'm going to say that integrating this thing over here, I treat x as a constant, pull it out. Do I know the antiderivative of secant squared? I do. It's just simply tangent. So what do you get? X times the tangent of y, and that's going to go from 0 to x squared. All right? So, you know, this is what the y is. So it's going to be x times tangent x squared. That's not so bad. Minus x times the tangent of 0. Relatively simple. Let's write that down. So you get 0 root pi over 2. This thing disappears, and you're left off with x times the tangent of x squared dx. I'm going to use u substitution now. Let's write that down. So I'm going to say u equals x squared, and du is 2x dx. Let's write that down. So if x is 0, what would I get? I'd get 0 for u. If x is root pi over 2, when I square it, I would get pi over 4. Then what do you get? Well, I see the x dx, and that's a half of a du. And then what do you get? You get tangent of u. All right, not so bad. Just want to remind you, that we've seen this before, but again, a lot of times you see things, you don't remember those things. I just want to remind you on the side that we've done this before. The tangent, I'm going to put x over here, dx. I just want to remind you we've done this one before. How do we do it? Sine x over cosine x. I let, cosine x equals substitution, so that would be u. And then it would be minus sine dx. So I'm going to put down minus 1, put a star here, du. And what's that going to be equal to? Minus the natural log, absolute value of u. And then what's u? U is cosine, right? So what do you get over here? Minus the natural log of the cosine of x. And I think what we do is we put the minus 1 up on top. So it's actually going to be, minus the natural log of secant. That's not so important, though. So I'm sorry, minus the natural log of cosine x is the natural log of the absolute value of secant. Right, so I'm just going to put this over here. Whoops, where am I? I lost myself. So it's minus 1/2 ln, absolute value, cosine of x. And what's the limits of integration? It goes from 0 to pi over 4. I think I can do that. And what do you get? Minus 1/2 natural log. Well, the cosine of pi over 4 is 1 over root 2. The absolute value of that is 1 over root 2, so I'll write that down. And then minus and minus, so plus 1/2. And then it's going to be the natural log of the cosine of 0 is 1. The absolute value of 1 is 1. And that's going to be, the natural log of 1 is 0. So what do I get over here? Let's write this down a little differently. I'm going to write it down as 1/2 natural log. I'm bringing the minus 1 up. And 1 over root 2 to the power minus 1 is just simply root 2. I'm going to continue to write that a little differently because root 2 has got a power. It's 2 to root 2 is 2 to the half. Bring the half down, you get a quarter. So 1/4 ln 2. And I'm going to write that ln 2 over 4 and call it a day. Now, mistakes can happen. Let's just take a look at the work and see if we got that in the end. And what I get in the end, I got it right over here. And we did it without doing any rewriting. We didn't even draw the picture of it. Thank you.